Chain rule is a process used to differentiate a composite function. That's the f of g of x. Remember Fogg and Goff? In other words, f of g of x, where you have an inside function and an outside function. If I have the square root of x plus 5, the inside function is what's under the radical. The outside function is the radical. So we're down to composite functions. If I had x squared plus x to the 5th power, outside function is x to the 5th. Inside function is x squared plus 1. This whole thing hinges on inside versus outside. And this is one place where I learned if I can differentiate the individual pieces, I can differentiate the whole. So you have to be able to take it apart in pieces. So if I have a composite function, which is f of h of g of x, what is it? The formula or the derivative is h prime of g of x times g prime. Well, what does that mean? It's the derivative of the outside times the derivative of the inside. Okay, everybody get a paper to take home with you? Okay. All right, so here we go. If f of x is equal to 5x minus 2 cubed, this is what I see. The outside is this. Can I differentiate x cubed? What's the derivative of x cubed? 3x squared. So I could differentiate this thing if that were an x. But that's just a set of parentheses cubed. So it's 3 times a set of parentheses squared. It's like 3x squared. The inside is 5x minus 2. Can I differentiate 5x minus 2? What's the derivative of 5x minus 2? So as long as I remember the rule, I can differentiate this thing. So chain rule says that f prime of x is the derivative of the outside. So to me, I see this. I don't care what's inside. It's the derivative of the outside times the derivative of the inside. Well, it's 3 times, the inside was 5x minus 2 squared, times, what's the derivative of 5x minus 2? 5. So this is 15 times 5x minus 2 squared, and that's what f prime is. Derivative of the outside times derivative of the inside. Now, first thing I do with this guy is I bring, if that were just an x, I'd bring him up as x to the minus 4, right? And if I take a look, the inside is 2x plus 1, and the outside is parenthesis to the 4th. It's like having an x to the 4th. These are blobs. So when I look at it as blob to the 4th power, or b to the 4th power. So if I were to rewrite this, I'd rewrite it as f of x equals 5, bring that set of parentheses up, it comes up as a negative 4, and this is like having it inside the box, 2x plus 1 comes along for the ride. Because he's encased in parentheses. Whatever happens to the parentheses doesn't necessarily happen to him because he's inside. It's kind of like the big bad wolf. He can huff and puff as much as he likes as long as you're in a house of bricks that's made of bricks. He can't blow it down. and it doesn't impact you. It picks the outside, but it doesn't impact you on the inside. So what is f prime? Well, it's 5 times negative 4 times the blob to the negative 3 times the derivative. Now I go after the inside. It's the derivative of the outside times the derivative of the inside, which is minus 20, blob to the negative 3, and what's the derivative of 2x plus 1? 2, which is minus 40. Now I can put in my parentheses. If I'm dealing with chain rule, whatever in the parentheses, I don't care what's in there until I have to differentiate them. It's like I can pick up a package that's in my mailbox, and until I take it inside the house and open it up, it means nothing. Oh, go away. That's good you caught that. That means you have an idea of what you're doing.